There is surprising data that shows that xAI's Grok is basically catching up to GPT-4, OpenAI's GPT-4, and will soon be competitive with GPT-5. So the large language models, the AI, is a battle that Tesla and xAI are fully involved in. And we also know more about all of the NVIDIA chips that Tesla has.
So Elon feels like he wants to be the winner, not just a player.
Yes, he was a co-founder of OpenAI, and he was not someone who didn't contribute to what was happening with it.
Yes, and apparently, I doubt if this is revenge. I think really what it boils down to is, what he talked about is he set up that company and provided a lot of the funding because he wanted to make sure that somebody was having some kind of control over how it's used and whether it's used for good or bad. And now he's a little nervous that these folks may not be that great. He calls it. He says they should change their name to Closed AI, right?
Yes, he did. Yes, I'm sure he calls them even worse in private.
Probably.
So for people who are not aware, there's a lot of activity over at xAI. They announced Grok 1.5 just a few weeks ago, and it comes with improved reasoning, 128,000 tokens, so a very large context window. Um, it is probably, in my usage, not quite as good as GPT-4 or um, the Anthropic Claude 3, but it is very good. It is better for certain situations. It's competitive. I think there's quite a few models that are competitive with it. Elon,
Scott, by the way, Scott Walter put out a post earlier today. For those of you who don't know Scott Walter, he's commented on my channel. He's a robotics expert, aerospace engineer, Dr. Scott Walter, and he has been playing around with the Grok. I guess it's still the earlier version, but he gave it a very complex question today, asking it if it was told that a triangle had four sides, and it knew from its data system that that was not true, but it was asked to explain how it could possibly have those four sides. what would it do? And it gave a very, very complicated, complex, and smart answer. So Scott was very impressed by that.
yeah, interesting. So as all of these models do, they give out a bunch of specs whenever they release, and then we can see here that Grok 1.5 is close to GPT-4, usually a few percentage points off, but not that much. The Claude 3 models from Anthropic are all in there. There's Mistral, a French company, Gemini from Google. Everything's kind of bunched together. So many models are competitive. If you can get enough chips and you can have enough money to hire a decent team, it seems like you can get into the game. Will someone start pulling ahead and doing breakthroughs? We don't know. But at this point, everyone's in the game. GPT-4 from OpenAI was in the lead, but came out a year ago. So do they get their lead back with GPT-5, which is supposed to be a big leap? But even if they do, other improved models are coming. So we'll see how much advantage they might have with that. Also, yesterday, Grok xAI released Grok 1.5V, 1.5 with vision. So it's multimodal, which means that it can handle pictures and video, understand them, as well as do some levels of creation with it. An example of this is that it reads a flow chart. So people who've done a computer science degree like me, you would write flow charts to say, okay, here's how the logic should work with a decision tree being the diamond, true and false off that. This took a hand-drawn flow chart and then wrote code off of it. I would have loved to have had this when I was going through my degree, to just write the code straight from my flow chart.
That's right. Fantastic.
And then some other examples were it can read the nutrition facts off of a product label for a
Wow.
product. It can look at a pile of objects and say, is the pizza cutter, the same size or bigger than the scissors, even among all these objects, so it end up identifying them all. So clearly it has understanding of what the objects are.
Okay. Wow.
And again, real world tests measuring things and then comparing the different systems together. They seem to be in the lead versus GPT-4 Vision, better than Claude Sonnet, Opus for that last category of real world testing, understanding.
Holy
And then,
mackerel.
the last one there was Gemini. Google Gemini is pretty close to Grok. So, and again, but some of these tests may not represent the full capability of the system. Some systems say could be, really good at, I don't know, engineering, other things. Just like if I take an SAT, I could suck, as a doctor, even though, hey, I have a great SAT score. It doesn't mean that you're nothing good because intelligence is so hard to measure.
Sure. Sure. Sure.
So Elon was on a Twitter Spaces, and he mentioned that the Grok 2 soon to be out in May, better than GPT-4, better on these tests and metrics. And they were training it with 20,000 NVIDIA H100s. The NVIDIA H100 chip is about 4 petaflops of the AI compute, which is short words, 8-bit or 16-bit. If you're doing scientific calculations, like if I'm measuring the National Lab supercomputer, I'm using 64-bit.
Uh-huh.
So it's slower. But if you're talking about only these short words, which is what the AI cares about, then it's 4 petaflops. 20,000 of them would be 80 exaflops. So a large amount of compute.
Right.
Grok 3 should be training, maybe it's already in parallel training, or it's going to start soon after the May release of Grok 2. It will be near GPT-5 level. They'll both be using the same amount of processing in the 100,000 chip range. OpenAI did not release, they stopped releasing about a year or two ago how much training they're doing. Before, hey, we're doing really good work. We're still academic. Here's the numbers. Once they're talking about serious money, then they shut up about how much they were processing with. But Elon knows because he's in the field,
Yeah.
and it's tough to keep secrets and those kind of things. So he's saying 100,000 for OpenAI, and he would be talking to many people who would love to give leaks to Elon, and then he's getting 100,000 chips. NVIDIA, the waiting list times for H100 chips, which used to be months and months, is now down to 6 weeks.
6 weeks.
6
I
weeks.
hadn't heard that. Wow.
Yes, so I heard that as well. So that would mean that if you have the money, $3 billion, and you really want the chip, you have the use for it, you can get them now. Although the choice would then be, do I buy them now, install them now,
Right.
or do I wait for the B200 chips, which already were announced at a couple weeks ago, and are far more energy efficient, 25 times more energy efficient based on the amount of processing that they do, which is a huge deal because the expense for the electricity could be even more than the expense for
Sure.
for the purchasing of the chips. But if you
and what month are they planning to start shipping those?
the B200s,
Yes.
they could do low volume almost immediately. They may have low volume now,
Oh, I
right?
see. Okay.
But then the question is, if I need 20,000 of them
Yeah.
to get to 800 exaflops, when do I get 20,000 of them?
Yeah.
Right? You would think it would be May, June if you're on the first of the list, because the designs, they print out, tape out the designs, what they used to call it, and then that design file would then go to TSMC, which actually prints it, right? And then TSMC would just be popping the design file in, and now you're printing the new chips. But there is a lot of stuff going around with that because it's not just the chip itself that has to come out; it has to get packaged into a package, like a wafer,
Right.
where the substrate, there's some interposer connection stuff. So it's basically like a super complex cake, right? Layers and layers of stuff. And beside the chip is like 6 or 8 stacks of high bandwidth memory. So high bandwidth memory is stacked memory. I got like these layers and layers of memory, which is more information, but it's has tougher to cool. There's challenges with that. But NVIDIA chose to go down the route of using expensive optical internet interconnects and high bandwidth memory, and they've done some cornering of the market for a lot of that supply, right? Because say we're designing to this, and we want to get as much of it. Micron, you're making the high bandwidth memory. We want to reserve that supply. We're your best customer, blah, blah, blah. And so it's tough. That's one of the other reasons it's tough for AMD and Intel or other companies, Samsung, to catch up to NVIDIA because they've done the thing. So then on the All In podcast, they discussed.
They did. I saw that. Yeah.
They need to do a different approach
Right.
to achieve your speed ups in order to get around this blockage.
So they weren't they saying that NVIDIA thinks that they're doing themselves a big favor by doing it this way, but in a way, by completely freezing everybody out, they might be creating their own future competitor, being forced to come at this from a different direction.
Right. So you may force other innovations and that kind of thing.
Right.
But the rest of the industry, seeing NVIDIA make these leaps and bounds, right? It's there's NVIDIA strategy has worked to this point. It's decades that they've held their, 2 decades they've held their GPU lead, or the graphical processor lead, and everyone else are trying as hard as they can to not be able to catch it.
Yeah.
Now they're motivated to catch it
in a much bigger way. Yes.
In a much bigger way. The big tech giants are motivated. Elon wants to create Dojo, so he has a bit more leverage over things. Other startups want to find and run, but it's just, NVIDIA has chosen the main road, the road that's proven to work.
Yes.
So finding something that's unproven.
Right.
Historically, back in the days of Intel, the 90s, where they were dominant, everyone kept saying, okay, we're going to get around silicon, we're going to get around whatever. And no one ever succeeded. You'd find a niche, but you couldn't do the main thing. So it's definitely on the others to prove that they can do it, especially because NVIDIA's execution has been so good.
Right.
Like that B200, just a masterpiece of energy savings and processing power. So, we'll see.
Yep.
And speaking of which, this is the NVIDIA B200, the Blackwell chip, 20 petaflops versus 4 petaflops for the H100, while only using, a bit more energy, 1200 watts.
And it looks so sinister too.
Yes. Yeah. Just lucky, I think.
I think that maybe.
So the model sizes. So the GPT-4 class systems are about 2 trillion parameters. The guesses for the GPT-5 class systems are 40 to 80 trillion tokens. So what do these tokens mean? 80 to 200 terabytes. Elon said that the GPT-5 class systems, or Grok 3 type systems, using 40 to 50 trillion tokens, that's basically all the available data, internet text, regular amounts of video that's already online. That data is pretty much it. And there have been papers that show that if you start with the same data, you train your model, you're going to end up with the same performance. No matter what kind of tricks and stuff you do. So far, no one said, okay, I start with the same data and then I end up smarter. It's like, I read the same medical books, other things. I'm the better doctor at the other end because of something, right? No, you end up being the same doctor when you study the same. And then GPT-6, they're talking about over 100 trillion tokens. So, but you've run out of regular data. So what's the not regular data? The not regular data is synthetic data, where I look at regular data and then I statistically manipulate it to say other data would be like this.
Yeah.
So you're kind of making stuff up. How good that data is, how much it works. They seem to think it helps. It does stuff. You can do stuff like extend out. Back when you're doing Go programs or chess programs, you can have the systems compete and generate new games
Mhm.
by competing each other. So similarly, you can generate new data. So that's synthetic data. Number two is real world data. So Elon talks about real world data all the time. That's what we have with the Tesla cars, with FSD.
Right.
So, again, the cameras looking at the driving and stuff like that. That's the real world data. So potentially unlimited in terms of how much you have. How useful it is to train and create an intelligence capability is another question. You'd want to have data related to surgery. If I wanted to train a surgeon, you want data related to um, gymnastics if I was trying to train a gymnast, right? Um, but the other thing, other data, is ArcInvest talks about voice and speech data. So if you had something that was, secretly recording all of us speaking and talking, that's a lot of data out
Yep.
there,
Yep.
right? So there are other forms of data that have not been fully made into an easily electronically accessible form.
Right.
So
And I think All In Podcast also made the point, which I thought was a good one, that at GTP5 level, they should be able to do current data. So they should have plenty of compute, plenty of capability to be able to get all of the current data on a day-to-day basis. So that we're no longer looking at September of 22 on chat, for instance, we'd be looking at today's data and have immediate instant availability to that data.
right, that seemed like such a glaring flaw
Right.
in the old system that there were kind of like kludges patchworks for that. There's also what they call RAG data. I can't remember the exact acronym now, but basically RAG was if I have my business data, my legal files,
Right. Right.
my financial records, I want to my documentation, I want to load that into the system and I want it to learn that stuff. So having models that are tuned, because clearly everyone wants that. They want to say, I have company ABC, here is our sales catalog, here is our product catalog, here's our technology. We want to put it into the system, be able to use it, because that is what we know is the most valuable to us as a business. So clearly that's highly valuable for all the models to handle. They have to do it in a way where people can trust it, where they say, I am putting it in, but I don't want you to give it to my competitor. Right. But it's so there's again lots of nuances to the data, and also people have scanned data into the systems, and then they test it, and then oftentimes the answer like it did read it. If you dig enough, ask it 5 or 10 questions, it may be able to say yes, here it is. I did read that. I did read that. But then other times you'll just like, I read it, but then can't answer any questions on it, right? Yeah. So it didn't actually learn it, which people have seen deal with other people where, yeah, I read your note, I read your email. Then what did it say? I have no clue.
No clue.
The AIs have that problem too.
Right.
So here's in the middle of this thing, this busy chart is, the Google Gemini and the GPT-5 estimates of, from Alan Thompson, Life Architect, 50,000 chips, H100s, but Elon says 100,000. So the varying estimates. Also, the prices are starting to get close to $1 billion to do a training run. And then there's all the other models. One to note there, the Llama is the Meta, Facebook. Olympus is Amazon. So Amazon's coming with a big model game. So basically anyone with money is coming with their own big model. So besides data, we mentioned data. Kyle Corbett, a Microsoft engineer, mentioned that those 100,000 H100s are crashing the power grid when they try and put them all in one spot in the United States. May not be true in China, which has a newer grid, but here that's the case. For those who don't know, a typical nuclear power plant uses about a gigawatt, produces about a gigawatt, and that's about 8,000 terawatt hours per year. A coal plant usually smaller, 300 megawatts, 400 megawatts. You'd need several to equal a nuclear power plant.
Right.
And they often put more than one plant together. You got to put 2 nuclear power plants together. You could put 6 coal plants together to get to larger amounts.
Right.
The energy grid steps down that power. Because of course, I can't plug into a national nuclear power plant.
Right.
Because one, it'd kill me, and then two, I'm getting 120 volts down here. So you have these step down the power by split things off, like tree branches, spreading out from the main trunk of the tree. So they have transformer stations, big transformer stations, small transformer stations that go, I'm starting with a gigawatt, 100,000 volts. I go to 10 different transformers, or to a transformer that splits it down 10 ways. Then I get 100 megawatts, 20,000 volts, and then I go down and spread it again to 10 megawatts, 10,000 volts, and then down again to a major substation, which then would transfer the power out to factories and buildings and stuff like that, and then to communities where you have like you have the power lines coming down to your home, which have far less power, and there may be a junction point up ahead for your whole block.
Right.
So that's how the system kind of spreads out. So making that is difficult because the US grid, the European grid, has stayed relatively the same for about 5 decades. We didn't build the power because we needed more power, but then we just did it with efficiency. You need 2% more, we just got a bit more efficient on our power. We didn't stop making it. The problem with that for now is that the companies that built the US power grid, the European power grid, they are basically dead from 50, 60 years ago because you stopped making grid. So the companies that made money making grid are dead because they couldn't wait 60 years. Okay, now we need more grid. Hey, it's been 60 years later. Yeah, granddad made grid. I don't make grid because we stopped doing it. You stopped paying us for it. It's gotten so bad that even making certain transformer stations, we used to have special railroads or special things to move
the big
100-ton objects that were the transformer grids. We can't even do that anymore. So then the Defense Department said, okay, they did it a few years ago, say, let's split these things up into 3 pieces that we can move, 100 tons at a time or something like that. Some of that work has been done, but they're basically need to restart all that process. So China has an advantage this way because they've been going through that economic development, fast growth for a long time. They've been slowing down a lot, but they still had a fair bit of fast growth. They were building, 5-10% more power every year, right? So their companies making grid, making stuff, they're all ready to go. Oh yeah, we got 40 nuclear power plants under construction. We got 100 coal plants under construction.
Right.
We're making grid all the time. We're making a Shanghai of new city every year still.
Right.
Things are still going good. And now they say, okay, now we need 20% more power leading up to 2030. That's great. We thought we were going to stop growing, and now we don't. We need all the energy we need. While the US and Europe have to, like, okay, now in the new AI world, we got to make a lot more grid, a lot more power plants. Probably the fastest thing to go with solar and batteries.
Right. It would make sense.
So here's a rough extrapolation. So this is a lot of projections. It's not like I'm saying, okay, here's the exact numbers. It's basically like 3 dials, like compute chip efficiency, energy needed. Like my compute chips don't get quite as efficient as I want. I need more energy. If I make them far more efficient, I need less energy. Obviously, that would be the ideal solution to get that, which also means I'd have to buy, if it's NVIDIA that did it, I have to buy their chips. Whoever did it, I have to buy their chips from. And then I have to get the data. So we said almost all the pictures and video have been used up, all the regularly taken, and it's about 50 trillion tokens. So it's the tokens that are the measurements of it. And then how much synthetic data. If I double up my data, I have half regular data and then half something else, synthetic data or something, right? Just because if the statement of 50 trillion tokens of data is correct, of regular data, the stuff that's on the internet or whatever, then everything beyond that is other. So then if things scale up the way the models need more data, then we get to the need of 90% other data, 99% other data, 99.5% other data.
Right.
So then there's challenges each way with that. Synthetic data is maybe tough to make, especially more and more of it. Is it as good as the regular stuff? Because I'm making it all up, right? So I'm before we had the problem with hallucination, now I'm making up synthetic data. Statistically, it's correct, but it's how much am I really learning off of that? So then real world data, I think, might be more valuable. But then there's the collection problem. Okay, I just need to get a bunch of cameras. I just get a bunch of iPhones and cameras and stuff like that. But I got to send back high volumes of that data. And I got to be looking at and recording things that are actually useful and interesting.
And by the way, wouldn't that be a great job for the Optimus?
Yes, that
They
would
can
be a
just
great
go out
job.
there. They're not even doing any other work. They're just walking around the planet, taking in real world data.
You're stealing one of my
Oh
conclusions.
no, I'm so
It's
sorry.
fine. It's fine. So basically, the conclusion then would ultimately be that if super intelligence is the end state that we're going towards,
Right.
and it's super valuable, right? Then everything becomes a massive loop around. I make my super AI. It's really good. It makes good humanoid bots. It makes self-driving cars, all the other stuff. All the things that are super valuable, making tons of money. I distributed it, and then it's making more energy. It needs more energy. I make more chips. I'm using the AI to make all those things better. And I keep doubling or tripling every year, every 2 years, and then I go gather data. So I'm making things to go gather better data. I'm figuring out where is the better data to make me smarter, right? And then I'm sending off the bots, sending off the self-driving cars to go get it. Something to note is that the current 6 million cars that Tesla has, with 6 million, actually 48 million cameras,
Right.
and processing chips, and sending back up to 10 gigabytes per car per day, or 100 petabytes per month, that those cars cost $250 billion. So if I say I'm going to go to 600 million cars, and the world has 1.5 billion currently, going to 2 billion cars, then in the purpose of AI information gathering, that would be 100, 300 times more than the 250 million. Let's call it 400 times more. That's $100 trillion.
Oh my goodness.
So then if I do that with cars and with bots, and the bots say cost half as much, 1/4 as much as a car, then I'm getting to, 4 billion bots. I'm looking at, 40,000 trillion dollars. It's so insane amounts of money to feed into the AI to gather information. So it becomes, this, monstrous circle of activity in order to just get more intelligence, keep getting smarter. And it's a race, a treadmill, where things keep going round and round. So something to note about the energy thing is, if I get to 3,000 megawatts, that's 3 gigawatts, that's all the power from 3 nuclear power plants. We can make 3 nuclear power plants. The US has almost 100. The world has, close to 400. So those can be made. But in the US, it's taken 10 to 20 years to make them. The US has made very few. In Korea and in China, it takes about 5 years. They basically keep their projects on schedule on it. But so even though they're big and they have nice steady power flow, it could be faster just to make square miles and square miles, acres and acres of solar power with batteries. So if I was to do that, if I replace one nuclear reactor, I want to get about 30 terawatt hours per day. That might be on the order of 10,000 megapacks with the accompanying solar, right? So the entire production of the Lathrop factory will be needed from that. So that goes to Master Plan 3 being out of date because it did not account for this massive demand.
This kind of growth,
AI, right?
Hey, it's been raising this question to me. It raised the question with regard to NVIDIA as an investment. Now it's raising the issue in terms of the entire industry of all this data gathering and all this AI and AGI. is, isn't there a real chance that there somewhere in this process, you've got enough for a while? In other words, you get to the place where you have more hardware and capability than you have data. Tesla for a while, in terms of Dojo and their NVIDIA clusters, they didn't have enough compute. Now they say they have enough compute to take care of the problem. Now that could run that. Now they could get to the place where they have way more than enough compute, which would mean they have an opportunity to sell off some of that compute as a wholesaler to others. But isn't there a point at which, if you got these 8 or 9 or 10 or 12 major corporations that are all in this race, that we might end up with so much compute and so much storage and everything else that we really have way too much inventory?
So, for certain use cases and problems, like self-driving, if you get to full robotaxi, where it's got perfect driving, then yes, for that use case, it's solved. It's just like we've solved checkers, or we've virtually solved chess, right? We're no longer heavily researching, I got to make a better chess program. I got to make a better Go program. There's some work on that. But because you've broadly got it, then that area becomes less interesting, right? And whoever solved the first mover, maybe that's it, right? Or whoever's chosen to compete, then they're done, right? But I would say that the need for continually smarter and better humanoid bots is pretty unlimited. If I'm accelerating scientific discovery, that's also pretty unlimited. I would say you'd want to fully solve these things and say, okay, I now have, a virtually perfect humanoid bot. It's super smart, does all these things. I have a perfect self-driving car. All the things that we're currently working on, the big things that have big money,
right?
They're done, right? My level of scientific advancement somehow plateaus, right, or something else. So I could see your case where it could happen, or where it could be a temporary plateau. But I would think there'd still be other things to do. Then becomes, what they are, I don't know.
Right.
But you definitely would get that point until we get billions of bots on Earth and having self-replicating factories where they can mine and build factories on other planets and other asteroids, right? I see the economic value for that being something that you wouldn't stop until you'd achieved that level, right? And you would want to keep researching to reduce the energy requirement, make it more efficient, because there'd be some value to lowering costs, to being the lower cost producer.
But I always see this, Brian. We talk about how many cars are going to be needed in the future, potentially being less than the 2 billion that we have now, because there'll be robotaxis, they'll be 5 times as efficient. So there could be the potential, and as populations decline, or if there's other means of transportation that we haven't even, contemplated that come out of AI. So, I mean, there's all of these places where we anticipate that it'll always be bigger and bigger and bigger. And yet, even as we've seen this year, the last year, we got to the place where we didn't need more lithium, and we didn't need more lithium batteries, and we didn't even need more batteries in terms of the production was there. There was enough production. Now we may need a little different kind of battery, and we may wanted to make it in a different place. But in terms of the worldwide demand for these kind of batteries, it plateaued. It got out ahead of itself, and then everybody was running at 70% capacity.
Right, but I think that's a temporary.
Yeah, that one's a temporary
pause, right? So I think it's going to keep going, but temporary pauses are there. Stock prices can fluctuate, but as we get more things going, the fact that one major area pauses like that,
Hmm.
then it won't affect the overall sweep of what's happening. Um, so,
I'm probably playing around with a really minor issue here, but it's just it's always, as a guy who's always been involved in supply chains my entire life.
mhm.
My very first invention was to develop a inventory control system from scratch. It's the kind of thing that triggers my mind that, yeah, at some point you've got enough, of you're not going to need as much additional as, I guess, maybe another way of saying it.
So for those who listened to the last Tesla earnings call, we could get in between growth waves.
Yes, there you go.
Yeah.
Yeah, yeah,
But I still think that the other growth waves out there,
sure.
and it would be something that you'd be working to achieve.
Right.
Um, so here's the rough extrapolation of Grok. Because I don't know how they'll compete, I'm just assuming that they end up being roughly comparable. XAI has been releasing at a slightly more increased pace. Instead of like once a year, they seem to be releasing once every 3 to 6 months. And then I'm assuming here that the real world data advantage from Tesla will flow for that. So they will have the advantage of getting more real world data.
Right.
Altimeter Capital, $10 billion VC firm, they project that in the middle of this chart from 2024, we're at about 5% energy for our AI and non-AI data centers. They expect us to nearly 4x to 19.3% by 2030. Right.
Wow.
So that's a huge amount of energy increase, going up from about 200 terawatt hours today up to about 800 terawatt hours.
Yeah.
So it's a massive amount of energy that has to be built. So I think you'll need a lot of megapacks, a lot of solar, and definitely that would be something that Tesla and xAI would use for their AI data centers.
Right.
This also plays into SpaceX. SpaceX satellites, Starlink satellites, are linked by lasers. They're moving about 42 petabytes of data per day. AT&T's fiber backbone moves about 600 petabytes of data per day.
Mm.
So if you increase the amount of Starlink satellites and make them larger, better by 15 times, that 42 petabytes will equal the 600 petabytes. So it's an alternative backbone for moving this data around. And if the Starship is working, which a physically usable large rocket, then the amount of satellites could really explode. And you could then put up in space laser links, and also you probably may have larger satellites that are massive computing nodes to move the computing closer to where it's needed, up the communication are needed. So I'm not transmitting to some data center off in Texas or something like that. I'm just talking up in space, which is only 300 miles up, 200 miles up.
Right.
Reducing that latency time down to 10 milliseconds or something like that to talk to the thing. So, but basically, everything, energy and communications, are all being bent towards the AI, assuming that the demand is there. This supply will need to go and match it, which all depends upon profitability, which goes to the larger question of when do we hit certain limits? We don't know.
Yeah.
What does this mean for valuations? xAI is raising $3 billion, probably to buy 100,000 H100 chips. And that would give them an $18 billion valuation. 25% of that's held by X, Twitter. Both of those companies are held by over half by Elon Musk. Don't know how many. OpenAI is currently valued about $80 billion plus. So if X gets and xAI get their Grok 2 GPT-4 class system, that would seem to start saying $80 billion might be worth what they're worth if they get an equal class system, or maybe they need to get to Grok 3 to get there.
Right.
But it would seem that both of them are going, very dependent upon their AI advantages. So the synergies that X and the other Elon Musk companies have are, as I mentioned, X provides text and video for xAI. FSD provides scaled real-world video to the AIs. $250 billion of mobile cameras in the cars. the SpaceX satellites moving the data around. And Tesla is not, so we're not concluded. My estimation is about 400 exaflops they have now. Previously, in someone's tweet from X, they mentioned having 200 petabytes of cache, super high-speed memory. So that goes to these data centers needing to be looking like one giant computer.
Wow.
So one giant compute, like thousands of GPUs, all acting as one GPU with high-speed communications, and then using the data. In this case, the real-world driving data, one exabyte, maybe many exabytes of this, trying to make it look like one thing, so that the model runs efficiently. If it has to do even a high-speed link out to something else, but it's 10 times slower than the cache or the memory, then that would cause the thing to take longer to do the computing. There could be ways to solve this. There's work towards 1-bit large language models where I represent the weights by using 1 bit, which reduce the memory usage by 20 times. There are other things, but then if the demand is insatiable, I get more efficient. I just need more. It gets better faster, but I just need more. So according to what has happened with things so far with computers, where we just, I think the early people with computers said there's no need for more than 6 computers in the entire world.
Right.
Kind of wrong on that one. Even Bill Gates, I think, saying something about no one needing 4 gigabytes of whatever memory. There were some statements he made that the people would say, we don't need more compute, and then they were wrong.
Yeah.
This translates over to some catalysts and milestones related to the self-driving, because the AI is in the FSD self-driving. So if AI works to the level that we're talking about, then we would expect FSD to be totally solved, one in supervised mode and then in unsupervised mode.
Right.
And then if the progress is happening as fast as I'm thinking it's happening, then we would expect a lot of the releases to happen. There could be delays. 12.4 may not be in April, maybe it slips to May. 12.5, maybe it's not in May, maybe it slips to July. But the substantial improvements would be expected if the only limitation had turned out to be computing,
Right.
because the video was there. I'm expecting the Megapacks growth to be solid this year. And if Megapack starts being sucked into the new data centers, which xAI is going to make a new data center, then there could be some rapid increases in Megapack installations. Tesla will be selling it to an xAI to do that. So it would be not an internal company transaction.
Right.
But then the installation time is still there. So maybe it doesn't appear next month when they make the new data center. Maybe it takes a few months to install, and then maybe it takes still 3 to 6 months to recognize.
Right.
But besides the utilities demanding this, we could see a AI-driven Megapack boom by next year. TBD. So I'm expecting the quarter ending volumes we already had quarter ending volumes for energy, where they said here how many gigawatt hours we installed of Megapacks. I'm expecting FSD to also start being in the volume note just 2 days after the close of the quarter. My bet would be October 2nd, that would be when it happened. But it could be July 2nd, it could be January 2nd, it could be April next year.
Right.
So they'll change the earning calls to talk about energy and FSD because it'll become bigger and bigger and more important. Just the way Amazon talks about cloud, because cloud is 80% of the business, they would talk more and more about it. It would force the analysts to recognize it. Meet Kevin Pathrat had a video where he talked about how FSD, the model, okay, they cut prices. He said, tell us how it ramps. He and the other analysts are saying, I can't put it into my model because I don't know. Until you give me guidance, I cannot put it into my model. I can estimate, 2 years, whatever. I can make some assumptions, and okay, maybe it's $80 to the stock, right? Until you say I'm confident I'll do it, then I can kind of say, okay, I'll then, you know, in my bull case, say you do it 3 months faster. In my bear case, I say it takes a year or two later, and then I have my high, medium, low. Until you give me the numbers, they don't want to model any of this stuff. So,
Yeah, and yet they'll give a valuation of $100 billion to Rivian and Lucid at a time when they don't even have a working prototype. So it all makes sense to me. I figured out the street now. I know how it works.
that's good. That's good. So I'm still confident that the main thing that could satisfy the analysts is the OEM licensing, the other car makers, Ford, other guys licensing it, because again, that's easier for them to model. They don't have to figure out what's the take rate, what's this and that. It's like another company has said they'll do it. I'm just going to say it's $10 billion per other company, and then boom, it's in my model. It makes it very simple for them. They don't have to figure that stuff out. When I look at that, if you license the other companies have 80% of the market. So instead of the 80 million cars being made, they do 60 million. Then you can do 10, 20, up to 50%, 60% take rates. And then that basically is like at $100 per month, that would be about $6 billion for 10% of the rest of the market at 80%.
Right.
Per year, and $30 billion for 50%. But that would be accumulating every year. As you sell cars every year,
right.
If you did it at 50%, it'd be $30 billion this year. That revenue recurs because I still have all those cars. Right. Another $30 billion, so then $60 billion, right. 90, 120, and that keeps recurring. So that recurring revenue.
That was CERN Bash. That was CERN Bash's big goof last week. I don't know if we should continue to harass him about it, but when he was making his estimates, he forgot to do the accumulation part. So we put out another video talking about that. So the other side of this is the other way. I put this out on my video early this morning. The other way I think the street gets it would be if they really get the full data set. And the full data set would be, this is how much we're going to charge per mile on average on our robotaxi fleet. This is how much we're going to charge for FSD per mile or per month or however it is going forward. This is how much we're going to charge if they're a robotaxi instead of if they're just using it for personal use. This is the first city that we're going to roll it out into, or the first state, or the first multiple cities or states that we're going to roll it out to. We already have regulatory approval, and here's the vehicle. I mean, so if the street can see all of the pieces in a physical vehicle, I think they'd get it.
I think if all that happened and we're seeing it's feature complete, like I mentioned, number 9, and all these things are working, and the interventions, everyone say, okay, I'm not intervening. It's perfectly smooth. It's a perfectly great ride. I feel perfectly safe in it. The regulatory thing could take longer, but if all that happens before the August 8th robotaxi reveal,
right,
then all that information is revealed by Tesla saying, okay, we're going to do the robotaxi network. We have the app. Here's the car, all that kind of stuff. Unless they say I'm flipping on the robotaxi network in these locations right now, and we're going to start doing trials at a few thousand vehicles and something like that, and we're using 100,000 cars that came off lease that we got back from our customers who leased them for 3 years, and we're using all that to start it on, and we're letting people start in. Unless they see it turned on, or they give a date certain within 12 months, right? Because they're just impatient, right?
Yeah.
Then it would bump the stock, but not to the level it should be. It would be just like NVIDIA doubling revenues and the stock not quite doubling, because it was, I think it's going to end. It's too good to be true. It's going to end. So I'm going to keep discounting it. So quarter after quarter, NVIDIA is beating it for 6 quarters for 18 months, right? And it's still going up. It's because revenues went up 4x, the stock went up 5, right? But normally, if you had a 4x increase in revenue and profits, right, you see more, right? More. But because they think the party's
multiple
gonna
increase. Yeah.
the party's gonna be over. They didn't do it. So if you do that for robotaxi, then it will help the stock a lot because it's revealed this 10x future. But instead of 10x, the stock maybe goes up 50%, maybe
Right.
double, right? Because it's like, and I still don't quite believe it, right?
Right.
I have to discount this model because
Yes.
it's too good. The numbers look too good, and you haven't really got it yet, right? But if you do the Ford signings, they trust Ford more to follow through, or
Mhm.
Honda, Toyota more to follow through than Tesla, right? Especially because they've been so disappointed
Right.
with Tesla, right? So the stock recognition would be easier and higher. Ideally, you get both. Ideally, you get the
Ideally, you get both. Yeah.
you get the signings, and you start getting real data, and
Yeah.
and all that stuff is all happening together, right? But Tesla needs to change to be more transparent, which is, for all of us who watched the last few calls, you're kind of like, I, we're not expecting them to be transparent, right?
Yeah.
Minimally transparent. So then it's up to the other deals, which are fact points that are indisputable, that give a clearer vision, easier for the Kevin Pathrath, the Gary Blacks to model than something as confusing as, oh, so what does this robotaxi network mean? How many will you have? I don't get it. Or if you do say it, then it's like, well, just Elon saying it, I don't believe him. He said we'd have this before, and I still don't trust it. This, like, we have Cybertrucks now, right? They're making a few thousand, but it's like they don't fully say, I'm gonna put in 100,000 Cybertrucks for this year. I'm gonna put in 250,000 for next year. They're saying, yes, you're making them. I'm gonna say 30,000, 50,000 for this year. I'm gonna say whatever. So if you're still depending upon them to put in their numbers,
Mhm.
even though you say something about it, they will still, I still got to give that a haircut of half, whatever. But if Tesla's confident with that and saying, okay, here it is, here's the number, at least you should get half to a third
Right.
of that recognized.
So I don't know if this will, I know we've been going almost an hour now, but I just wanted to add one other little very important thing that I heard the other day, and I talked about on my show this morning, or maybe it was yesterday. And that is this idea of what is it going to take to get the regulators to say yes. And I think it was on a Spaces that I was on yesterday. I can't remember for sure. But what they talked about was, when you're going before you're trying to get a pill approved, there's always a number of deaths that are okay. There's always a number of injuries that are okay. Or when seatbelts first came out, there was a number of deaths from the seatbelt itself. Our airbags, hitting people in the face and giving them bad injuries. There was always a certain amount of that was acceptable. Well, in this particular case, what we're talking about is reducing the gross total of injuries and deaths and accidents. That's a pretty easy data point to prove. And I think that's why Elon might have all along been talking about at 6 billion miles, he'll have that data. He'll be able to prove easily to the regulators, look, if you don't do this, you're unethical. You're doing a disservice to the world if you don't do this, because we can prove there will be less accidents, less deaths, less injuries. And so what's the question?
Right. So we already have 1 billion FSD miles.
Right.
Statistically, if they were just as safe as regular US cars, you'd expect almost one accident per 2 million miles. You expect over 500 accidents.
Right.
If there were 500 accidents, that would be released. Where are those reports?
Where's the headlines?
Yeah, where are the headlines? There'll be headlines for that thing. If we're getting 1 billion miles per month, or 1 billion miles every 2 months, then again, you should be having hundreds and hundreds of these accidents. Right. So if we're significantly safer, 10 times, 50 times safer, which would seem to be the conclusion that we're looking at,
right,
then that data would be, quite solid. And then based on the number of deaths, you'd say, okay, I expected 50, I got 2.
Right.
So that would be, a statistical slam dunk case. A country like China, led by engineers and regulators, they could say, yes, your math checks out, the numbers are good, go ahead, right? And they're already setting a national policy for robotaxi. So I think other places could be doing, and when you do that, then that could then pressure the laggards to say, okay, that country's done it. They're getting all the economic benefit. We got to follow.
All right. Well, man, what a future we're building here. Holy
Yes.
cow. And Elon seems to have his businesses well positioned to take advantage of this crazy future. Of course, I guess he's kind of creating that future, so he should get the advantage in the end. And all of us who are investing in him should get that advantage as well.
Who would have thought one of the richest men in the world knew what he was doing?
Oh no, what do you know?
Okay, talk to you next time.
All right, that's been great.